Good afternoon, everybody. I hope everybody's ready to go. You can see on the screen here, we just put the Pentair Learning Center down the bottom there, the website for it, so you can all go there and register. You can always get on any of the webinars simply by going to one of our websites, the Stay Right, Berkeley, Myers, or Hydromatic websites, and clicking on the buttons and follow the prompts there. You can get right onto the webinars that way. If you'd like a little warning ahead of time about webinars, and if there's certain ones you really want to attend, then log into the Pentair Learning Center, get yourself a sign on there, and you'll be able to say, I want this one, and then that one will come up, and you'll get reminders on that also. All right? So, without further ado, we're going to get started here. Today we're going to be talking about sump sewage effluent, and we're going to talk about the containers, we're going to talk about electrical, we're going to talk about fields, and how all of it fits together. Because the bottom line is, it's all got to work together in order to work properly. All right? So we're going to start out with pumps. And I want you to understand that there are lots of different kinds of pumps here. So we'll see different pictures coming up. And we'll start out here with a sump pump. A sump pump. You can see this is a Hydromatic SW. It is a sump pump that is designed to pump clear water. All right. The next one we're going to look at here, this is a little pump that's designed as that little triangle in the front of this called a puddle gulper. And it's designed to suck down to the 1/16 of an inch. So if you got a flooded basement or something like that, this can help you to get it out and get that water down next to nothing. A window well, something like that. This will help to get the water out of that. All right. I do have to warn you in advance, on the suction side of this pump, every time you use it, you need to put a tablespoon of vegetable oil in. Now, the reason you need to put a tablespoon of vegetable oil in there is because the fact that the impeller is a little rubber paddle type impeller, and it basically has to have something to start suction. And because of the viscosity of the oil, that allows it to draw water up into it. If you don't put that oil in there, you'll never prime that pump. So that's got to have that. All right? The next pump we're going to look at here is an effluent pump. This is a Myers pump, as you can see here. This pump, if you look at it very carefully, you can see by the way it's put together, this is an actual double sealed pump. And we've talked about them before back in the first SSE series that we did. So that's a double seal pump. All right. Our next one here, this is a special pump. This is considered a step pump. And basically this particular step pump draws the water from the bottom. Most step pumps draw from the middle. This step pump draws from the bottom. So the pump is on the bottom, the motor is on the top. The case that you see there, that stainless steel shell, actually goes all the way around the motor, and the water is forced up past the motor to the discharge. So this is a very special pump. It gets used primarily, and was designed primarily for effluent applications, but there are many, many times where people will take this pump and use it in a freshwater cistern type application. So that's called a step pump. All right. The next pump we're going to look at here, this is a sewage pump. Again, if you start looking at the pictures, you're going to notice that when you look at that drainer pump, it just has some small holes in the bottom of it. When you look at the effluent pump, you'll see that it's got 3/4 inch legs on it. And if you look here at this sewage pump, you'll notice that it has 2-inch legs on it, which means it can pass a 2-inch solid. If the impeller were set just right inside that volute case, you could drop a 2-inch ball into the discharge hole. It would roll down and through and come out through the bottom hole. Okay? So that's a sewage pump. Now we're getting into some of these bigger pumps here. And this is a grinder type pump. And it's got a special impeller in it, and it chops everything up. All right? These things go up to 7.5 horsepower, by the way. Here's a waste handler pump. Waste handler pump means that this will pump larger solids, and more importantly, it'll pump larger quantities. So these can go up to 3, 4, 5, 6, 700 gallons a minute. All depends. Of course, you have to realize that the higher the flow rate, your solid size is going to change a little bit. So these can go up to 3 and 4 inch solids. The next picture that you see here is a grinder pump on a lift-out guide rail system. And we always recommend the lift-out guide rail system, and that's the whole purpose of showing this picture. Isn't necessarily the pump, but the lift-out guide rail system on the pump. Anytime that you've got a pump that's really heavy, that's set down really deep, you're going to want to put a lift-out guide rail system in. It just makes sense because it's easier to get the pump out that way. You don't have to pump everything else out. You can just pull up on the chain and pull the pump right up because it's not connected to the discharge pipe in the usual manner. It just sits up against it and is locked in place. So lift-out guide rail systems are very important. Over on the other side of the screen there now, you see a duplex system using a lift-out guide rail system. And you can also see in that picture the inlet. So you can see where the water's going to come in. The pumps are going to trade off. There'll be pump 1 and pump 2, and they will trade off. You can see that they're set up in such a manner that there's only one discharge, and so they both go up and manifold into that one discharge. And one turns on one time, one turns on the other time. Again, if you look carefully, you can see the check valves there that prevent the water from coming back into the pit through the pump when the other pump is turned on. All right? So those are a lot of our different pumps. Now we're going to take a look at a typical simplex application. Typical simplex application. When I look at this particular application, one of the things I know is that it is a sewage application. Now, one of the things that tells me it's a sewage application is the fact that there is a check valve, and you will notice the check valve is in the horizontal position. So, 2-inch legs. 2-inch legs means you're going to have a sewage application here. The check valve, again, in the horizontal position. Now, the purpose for this is, should something happen and you need to take the pump out of the plate, nothing's going to go back down through that check valve. The other point is, with the check valve in the horizontal position, if the pump should turn off shortly after passing the solid through it, the solid can't come back down and settle on top of the check valve and prevent the check valve from opening the next time. That's why you want those check valves. And again, this is for sewage only that we're concerned about. You'll notice that we've also put a gate valve in play. The reason for the gate valve is if we're pumping out into, say, for example, a curb stop, and we're pumping out into a city sewer system, right? So that line is going to be full from the curb all the way back to our pump. And so if we ever need to take that pump out of play, we open up that, we close that gate valve, and now we can take the pump out, and there's very little sewage we have to concern ourselves with. And that's why that gate valve is very important to put in there. The next thing you're going to notice here is the union. And the reason that the union is there is so that we can take this apart rather easily. And so we just have to turn that union, we pop the piece apart, and now we can go ahead and pull our pump without having to pull all of our different pipe. So that's why that union is in there, and it's very, very important. Another thing that's extremely important, and that is, if the pump does not already have it, put a small 8-inch hole 1 to 2 inches above the discharge. It needs to be below the check valve, but 1 to 2 inches above the discharge. I call this hole a priming hole, and the reason I call it a priming hole is because of the fact that with that hole in there, this pump cannot be airlocked. And that's the whole purpose of putting that hole in there, is to prevent the pump from becoming airlocked. And so, of course, what happens here is as the fluid fills up into the body, it pushes the air out. So there's a hole, there's a 2-inch hole down here in the bottom of the volute case, and that fluid's going to come up in there, and of course with the hole in there, it can push the air that's why we use that little hole, and that's why that little hole is so important, because this whole area now can get filled with water. If it's not filled with water, it's going to be filled with air, and now we're going to have a problem, airlock our system, okay? The next thing that we see on our picture here is the inlet. The inlet, that's where the water is going to come in from the house, all right? We're also going to see a vent pipe, There are poisonous gases in here, and we don't want anybody getting hurt, so we want to vent these poisonous gases to the outside. We don't want them coming back up in the house. And so that's what that vent is for. It goes all the way to the roof, and we open it up and allow the gases to just float right out. All right? And the next thing we're going to look at here is we're going to talk about the basin itself. And when we talk about basin sizing, we talk about the inside diameter here. So what's the distance this way? All right? And then we're going to throw in the vertical distance. So we can have a 36 by 60 or a 30 by 60. 30 by 60 means it's 30 inches in diameter and it's 60 inches deep. All right? Now, of course, it's very important to also realize we don't get to use that whole area. There's a lot of area there. But we don't get to use that whole area. In other words, that line there represents what is considered to be the off float, where the pump is going to turn off at. And we have to realize where the pump turns off at from there down, that water is always going to be there. You're always going to have that water in that tank. And of course, it's also very important that we understand that we don't want water going back in the inlet. And so because we don't want water going back in the inlet, that whole area up on top there is non-usable. We can't use that area. It's there, but it's not an area that we can use. The only area that's going to store usable water is the area between. That's where your usable water is. So when you're calculating the size of a basin, you have to take into consideration not the whole size of the basin, but from the inlet down to the off switch. That's the amount of water that you really consume. We've got another SSE one that we call sizing, and in there we talk about if I want to get rid of 123 gallons, well, that 123 gallons has to come from the storage area. You can't, we're going to move on, okay? So the next slide here is a duplex system. Duplex means now we have two pumps in here. You're going to notice that with the simplex system, we had just a simple on-off float switch in there. Now you'll notice that we've got a little more in here, okay? So let's go ahead and start talking about it here. There's pump 1, and over here is pump 2, all right? It's very important we identify them. You'll notice that we do have a little hole in each pump. Remember, that hole is to keep the pump primed, so you have to put that hole in each one, otherwise you only have one pump primed. There's our discharge pipes, all right? That's where we're going to pump our fluid out of. That's how we're going to get the fluid up there and out of there, all right? The next thing is the vent. And so you can see the vent up on top there. We saw that dotted line show the vent, all right? Now what we're going to look at is the inlet. And you can see with the duplex system, you can have multiple inlets. You can have multiple inlets. I remember a duplex system one time that had 27 homes on it, and it had 7 inlets. So those inlets were arranged all the way around the basin, okay? That's part of the reason why you put a duplex system in, is so that you can do what they call a cluster. And this was a cluster of 27 homes. It's the largest I've ever heard of. Okay, but they put a cluster on there, which means multiple inlets. I want you to know that everything in that basin lid, all right, the discharge, the vents, the other discharge, the grommets for the electrical to go through, all of that is going to have some type of a rubber gasket to make sure that those gases go out the vent and they don't get in the house, all right? So your electrical wires are gonna go through grommets. Everything is gonna have some kind of a rubber gasket there to protect it. All right? Now, the pumps here, or the floats rather here, are designed around your inlet, or excuse me, I'm sorry, your inlet cord. That's what we're talking about there. That cord is also going to be, and now notice again, it comes from the top, comes down. They've taped it to the discharge pipe, and then brought it down. It's in the pump. That also has a grommet on there to make sure that it's not going to have water leak into it. Same on pump 1. Those all have to be waterproof. These are submersible pumps. All right. Next thing we're going to look at here is the float tree. The float tree. So the floats come down on their own cords on what we call a float tree. The float tree is going to be attached to the top of the basin there. Okay. And then, of course, you're going to have 3 floats on there. That bottom float is going to be your off float. The top float is your alarm lag pump, and the middle float is your on float. We'll talk more about that in a second. The area between the off float and the inlets, again, this is your usable water area. So again, you take your basin diameter times the depth. There's a formula you can figure out, or if you want, if you've got the SSE training manual, back somewhere around page 44 or so, we talk about how much water a basin will hold based on its diameter. Okay, and that again, that's another school that we talk about. So exactly how do the switches work? Again, the bottom float is going to be your off float. The middle float is going to be your on float. All right? And then, of course, you've got your top float, which is your lag pump alarm. Lag pump means that you've got one pump that's going to be the lead pump and one pump that's going to be the lag pump. If the lead pump can't keep up for any reason, then the lag pump turns on. Okay? Sometimes you're going to run into a situation where you have an engineer design the basin for you, and he's going to want you to put 4 floats in. When an engineer wants 4 floats, what he's looking for is this. He's looking for the bottom float to be the off float. The next float up will be the on float. The float above that is going to be the lag pump float, and then the very top float is the alarm. So you can see that what they do here is they separate the alarm from the lag pump. I was invited to come down to Atlanta one time, and I was going down to actually see one of our repping agents down there, and most of those guys working in that office were engineers, and when they heard what I had to say here, they stopped and said, geez, you know, we never thought about that. So what was it they didn't think about? Well, what they was is that they didn't think about was simply this. The way that your system works, all right? Again, one pump is going to be the lead pump, the other pump will be the lag pump. So during our first session here, what happens is the water rises up, turns the lead pump on, and of course it pumps it down, and now it turns off. When it turns off, in the control panel, there is an alternator that switches the lead pump with the lag pump, and now pump 2 has become our lead pump. So when the water goes up again, and it gets to the point where it says, okay, we have to turn the pump on, it turns on pump 2 this time. And again, the water is now going to go down, it gets the off float, it turns off. Once it turns off, you're going to see that they change place again, and pump 1 becomes the lead pump again. All right? Now, here's what they didn't think of. What happens if something happens to pump 1, and now it doesn't work? All right? Now when the water goes up, it's going to go past the on float all the way to the lag pump float, and it's going to turn the lag pump number 2, in this case, on. So the lag pump turns on, draws the water all the way back down where it's hits the off switch, and of course, now they switch places. All right, now pump 2 is the lead pump. Remember, pump 1 is dead. Okay, so it can't do anything. Even though it is a lag pump, it's not going to do anything. All right, now what happens is we come up, it goes to the on float, and the lead pump, being pump 2, turns on, and we go back down and turn off. Again, the alternator is going to switch, so that now pump 2 becomes the lead, pump 1 becomes the lag. And of course, what happens here? Now pump 2 dies. Okay, now what's going to wind up happening? The water's going to go all the way up to the alarm. And of course, at this point, whoever is the person involved here has got an emergency. They've got 2 dead pumps. Now, I don't know about you, but most distributors don't stock these things. And because they don't stock them, what that means, they got to get them from us. And if we don't have them in stock, then that means that, well, you're either waiting for pumps or you're going to go put somebody else's pump in. All right? So what I told them, I said, you know, whenever I get somebody that has a 4-float system, what I generally recommend is that after the engineer is signed off, because if you don't do it the way the engineer wants you to do, he's not going to sign off. Now, of course, you're the person that's going to get the phone call if something goes wrong, not him. Okay? So because they weren't even thinking about this scenario, they're like, well, so I said, what I do is I do this. I take the alarm float and move it down there, and I take the lag float and move it up there. So now the alarm has to come on when one pump is dead. And that way I've always got one pump to expend on while I get the other pump fixed. Does that make sense to everybody? I did have a guy one time tell me, well, you know, I always check these pumps every month. I said, well, that's good. That's important to do that. It's nice to have a maintenance agreement with your customer. But tell me this. Let's say that you check the pumps and everything's working fine. And then a week after you check the pumps, you find that pump 1 dies. And then 2 weeks after that, pump 2 dies. Now, it's only been 3 weeks, so you haven't checked those pumps, and both of them are dead. What are you going to do now? And that's the whole point of having that alarm sound. The reason that engineers don't want the alarm to sound most likely is because they've arranged these pumps in such a manner that one pump may not be able to handle the full load all the time. And so every once in a while, that lag pump has to come on. And rather than have the alarm sound, and now you drive all the way out there just to find out that the lag pump had to turn on, and there's really nothing wrong, the engineer puts the lag pump as the 3rd alarm and the alarm as the 4th alarm. But again, what they don't realize is if those pumps die, you got nothing. So this is why it's very important that you understand that I would rather be bothered by having an alarm go off every once in a while. Now, of course, I also have to admit if they seriously undersize those pumps, the alarm's going to be going off all the time. But that would be a sizing issue. That would not be a pump issue. All right? Any questions on that? All right, this is a look at where basins go. And basically, when you're talking about a basin is a fiberglass container, a polyurethane container that winds up going down the ground. Okay? Typically speaking, they're used where a bathroom has been added or a shower has been added, and now we've got an afterthought. I'll give you an example. My brother-in-law has a small home, and he has a wife and 2 daughters. Now, I'm not going to pick on women, but they do have a tendency to be in the shower a little bit longer than a man does, and they have a tendency to use a little bit more water than a man does. And so the bottom line is that it got to the point where his daughters, by the way, were 8 years different in age. And when the baby was first born, the 8-year-old was like, oh, she's so cute. Well, when the 8-year-old turned 16 and the baby was now 8, she didn't think she was so cute anymore. So, little sisters, you know. So the bottom line is, she wound up complaining and saying, I want a room of my own. So there was plenty of room down in the basement, and so Dad said, okay, fine, we'll put your room down in the basement, and while we're at it, we might as well give you your own bathroom too. So he built a bathroom down there. Now his problem was that the sewage line, this house had a walkout, and so the sewage line exited the house about halfway down the basement wall. All right? So now you've got a shower, a sink, and a toilet that somehow have to go up the wall to get out. So Basins is what he wound up putting in. Okay? Now when you look at the basin things you're going to see, there's your inlet. That's where the water's coming from, the shower or the sink or the toilet, one or the other there. Okay? And then of course there's your discharge pipe. So you're going to go up the discharge pipe, and that discharge pipe will connect to your septic or sewer line. All right? We also have in here a vent. Remember, the vent has to go all the way out. You don't want those gases getting into the house. There's going to be a gasket all the way around there to make sure that that is sealed. Any place that there is a hole in that cover, there's going to be a gasket for it. All right? Typically speaking, it's an automatic system, which means you've only got a simplex pump in there. It most likely is a sewage pump, especially if you have a toilet with the wrong pump. So again, we're going to encourage you to make sure you use the right pump for the application. If you're going to be pumping sewage, you need to use a sewage pump. If you're only putting sink water in there and shower water in there, fine. Then you can get away with it. All right? Now, the important thing to remember when you're using a sewage pump, this does not apply to effluent pumps. It does not apply to drainer pumps. It doesn't apply to the step pumps. It only applies to sewage pumps. You need a minimum velocity of 2 feet per second. So when you're pumping water out of there, your pipe size becomes very important. While you don't want the velocity over 5 feet per second, when it comes to sewage water, you do want the velocity to be at least 2 feet per second. So watch your pipe sizing there. You may have to upsize your pump sometimes and put in a bigger basin than you want to. For example, in the city of New York, they require a 3-inch line to connect to the sewer. And so at that point, if you need a 2-inch velocity, or 2 feet per second velocity, you're going to have to pump more water through there. And you may need a bigger basin so that you can collect more water, and also a bigger pump so you can get that flow going through there and get the velocity required. Okay, we call it a scrubbing or scouring velocity. This is called a vault. Okay? Now, when you look at the vault, you'll notice there's 2 sides to it. That's the septic tank side, and over on the other side is the pump chamber. I want you to understand that not all areas approve of a vault that has 2 chambers in it. So if you live in an area where you're not allowed to have 2 chambers in the same vault, pretend there's a bunch of dirt between those 2 chambers, and you've got actually 2 vaults in there. Okay? It's the only way I know how to handle that. Now, what we've got over here is we've got our incoming water. Again, this is going to be your water from your sinks, from your showers, from your tub, from your laundry system, from your toilets, okay? You'll notice the first thing we want to do is knock that water down and force it to go right straight down. We don't want it shooting out into the vault. We want it going down, all right? The reason for that is simply because the fact that we're going to want the incoming water to take its time moving across the septic tank. And if we don't have that elbow in there, there's something called a BOD count. Again, we covered that in our first series of SSE. The BOD count means biochemical oxygen demand, and it's usually running about 100 going into the septic tank. It's the count of how much oxygen is required to kill off the bad bacteria. Going out, we want that number much lower, okay? Now, the other thing that happens here is you can see on the bottom, sludge is going to build up. So there is going to be stuff that, this is an aerobic system taking place, this is an anaerobic system taking place now. And so because it's an anaerobic system taking place, you'll notice that we are using good bacteria to kill off bad bacteria. But that good bacteria can't eat everything up. And so you're going to get some sludge, big particles, that settle down in the solids on the bottom, okay? Meanwhile, up in the top, this we call scum. And what the scum is made up of is the soaps and oils that go in there. They, of course, are lighter than water, so they'll float to the top. So that's what your scum is made out of. In the middle, you're going to have what we call effluent water. Effluent water is considered to have a 3/4 inch solid in it. That's what effluent water is, all right? Now, what we're going to do is we're going to move that effluent water. For every gallon that comes in the inlet, a gallon is going to go into the pumping chamber. So once we've got this system up and working, any water that comes in is going to push water out. Gallon for a gallon, okay? What we're looking for now, as we move the water from the septic tank into the pumping chamber, is the BOD count of about 10 to 20. BOD count of 10 to 20, all right? Now you'll notice that's where the scum level is, that's where the level of the water is. So again, every gallon that comes in is just going to push a gallon out, all right? Something is going to happen though, all right? If you watch down here, you'll see the sludge. As it starts to build up, if we're not careful, okay, you can see it moves up. As you fill up that tank with sludge, now in the state of Wisconsin, which is where I'm at, in the county of Walworth, which is where I'm at, they actually have everybody that has a septic tank on a computer system. And their computer system is connected to all the guys that do the pumping of the septic tanks. And anytime they pump a septic tank, they are required by law to report that. And of course, what they're doing is they're watching to make sure that each owner of the septic tank gets that septic tank pumped at least once every 3 years. There's a reason why, and of course, the reason why is going to have to do with a pole. And so we're going to take our first pole here. Okay, so we're going to open the pole now, all right? And looking at the pole, you'll notice that the question is, as the sludge builds up and the area between the sludge and the scum becomes smaller, what's going to happen? Now you'll notice you have a variety of answers there. A is the velocity of the water is going across the vault is going to increase. B, the aerobic system becomes more efficient. C, the BOD count goes up. D, the BOD count goes down. E, the pump chamber has larger particles in it. F is A and E. G is B and D. H is A and C. I is C and E. So go ahead, think about your answer, and do one more thing. Notice all of your selections, all right? A is the velocity of the water is going to increase, and A is the correct answer. Because, of course, as the area that the water moves through becomes smaller, according to Bernoulli's law, that's going to increase the velocity of the water. So A is the correct answer. Okay. B, the BOD count is going to go up. With the smaller, not B, C, the BOD count is going to go up. With the smaller amount of water there, and the water moving faster going across the area there, what's going to wind up happening? The BOD count is going to go up. So the correct answer was A and C. A and C, which is H. All right? Now, we're going to go from the septic side of it to the pump chamber side. All right? So now we're getting into the pump chamber. And as we get into the pump chamber, you're going to notice now we have the effluent water. Remember, we settled out the large solids, and effluent water is considered 3/4 inch solids. So the water that's going to be in the pump chamber is now going to be only effluent water. Okay? We're going to therefore have an effluent pump. We no longer need a sewage pump. Now, I'm not saying you can't use a sewage pump here. You have to have a pump that can handle at least 3/4 inch solids. And so the bottom line is, what you don't want to use is you don't want to use a drainer pump. You want to use at least an effluent pump or a sewage pump, because an effluent pump will handle 3/4, sewage pump will handle anything larger than that, so you don't have to worry about it. Okay? Typically speaking, effluent pumps are going to give you a little more head. Don't forget, we're going to have our float tree here. We're going to have a control box here, because we've got our control panel. We're going to have 3 floats, an off float, an on float, and an alarm float. Okay? This could be a pump and dump float application. We'll talk more about that in a minute. Okay? The other thing I want to point out, and this was brought out by a friend of mine, his name is Bill Gregory. He is the repping agent in the Michigan area, so if you're from Michigan, you probably know Bill. Okay? Whenever you put your system in, notice that we've got 3 elbows inside of the pump chamber. And the 3 elbows inside the pump chamber are there, so that way you'll notice the union is right between the first 2. That way you can reach in there, undo that union, and pull the pump out. The bottom line is, you are not allowed by law to put your head below that area right there. The EPA says that that is illegal to do that without some kind of breathing apparatus. So because you are not allowed to do that, Bill suggests that you bring that pipe up high enough so that you can just reach down in there, break the union, pull the pump right up. All right? Now, let's take a look at electrical systems for a second here, because, of course, sewage pumps, drainer pumps, effluent pumps all run on electricity. So when we look at our electrical system here, the first thing we're going to notice is we've got 2 incoming lines to our house. They are 115 volts. If you were to take a voltmeter and go across those 2 lines, you would find that you would have 230 volts. Okay? Now, each of those 115 lines are going to connect to something called bus bars. A bus bar can also be known as a pole, and this is very, very important because of terminology. Okay? For example, I have a best friend who was an electrician, and he always used to talk about a single pole, single throw breaker. And I always wondered, what the heck is that? See, because I know water really well, but I didn't know electricity very well. What he simply meant was a single pole breaker means that you're only hooking up to 1 bus bar. Single pole, single bus bar. Okay? Single throw, a throw simply means it's either on or it's off. Okay? So that's what a single throw is. And of course, in most cases, it's on, which means if you follow the black line all the way out to your plug-in, there's going to be one side of your plug-in that's always going to be hot. Now, when you plug your device in, whether it be a pump, a computer, a projector, those are things that I use, of course, computers, projectors. Pumps are what I talk about all the time. So whether you plug any of that kind of stuff in, the electricity that's on the hot side is going to go down that hot line to where the switch is, the on and off switch. And as long as the on and off switch is in the open position, whatever it is you're using is turned off. There's electricity going to it, but it doesn't get all the way and it doesn't go through it. If it doesn't go through the motor, it can't turn the motor on. Once the switch turns on, now the electricity goes through the motor, and what happens? It winds up coming back on the white line. Now again, electricians like to call that a neutral line, because with the switch in the open position, they can touch it and know they're not going to get shocked most of the time. So that's why they like to color code those black and white, because white means it's safe to touch. Okay? You're going to notice that that white line gets hooked up to one side of what they call the neutral bar. The neutral bar. The most important thing we want you to know in that neutral bar there is it is connected to the ground. When you are running 115-volt electric, it's looking to go to ground. And so when you flip that switch and turn it on, you're allowing the electricity to go through the motor, come back on the white wire, and go over and go to ground, which is what it wants to do. All right? Now, speaking of grounds, we're going to put a ground wire as a safety factor inside that plug-in there. Okay, so if anything happens and you get a short, it'll go to ground because that's what it wants to do. And of course, the sooner it goes to ground, the less likely somebody's going to get hurt. All right? So the ground wire, you'll notice, is connected over here to the neutral bar also, which means, of course, that it's going to go right to ground. Again, depending on what state you're in, some electrical codes require you to put the neutral wires all on one side and the ground wires on the other side, because they don't want the possibility of that electricity going on the neutral to go back, or something on the ground to go back on the neutral wire. So they want to separate them. Okay? Now, one more important thing to note, if you go from the hot screw on that breaker there to the ground, you will register 115 volts. Because remember, you're trying to go to ground. Okay? Now, I got a call one time from a guy who was telling me that his son had just graduated from electrical school, and they were wondering how to hook their pump up. All right? Now you're going to notice here, we've got two single pole, single throw breakers, and each one of them are hooked up on a different bus bar. Okay? So of course what's going to happen here, we've got two black wires going out. You're going to have two white wires coming back, and then of course you're going to have two ground wires, because what this guy did was he made two 115-volt systems. A 115-volt system, 115-volt lines means that we've got three wires with one wrapping around them. And so what he did, because he hooked up two 115-volt systems here, or two 115-volt breakers, is he ran a 115-volt line from each one out to the pump. Now, of course, his problem was he knew enough that he had to put the two hot wires to the pump. He knew enough that the ground wires had to go back to the neutral bar. What he couldn't figure out was, what do I do with these white wires? I know I got to hook them up on one side of the bus bar, or on one side of the neutral bar rather, but what do I do with them here at the motor? And so I said, well, first thing you want to do is just grab a couple of those wires, wrap those two white wires together, put a wire nut on them, and then send your son back to school so that he learns how to do it properly. Okay? Because the bottom line is, when it comes to 230 volts, you do not have two 115-volt systems. You have one 230-volt system. You have two hot wires and a ground. So he ran way too many wires, and of course, that's gonna cost you an arm and a leg to run something like that. So, no, that's not how you do it, okay? When you are running a 230 volts, and again, another reason why you don't wanna do this, okay? You don't wanna do this because should one of those breakers trip, the other breaker is still on, and you've still got electricity going to that motor. That could harm the motor, okay? What you're really looking at is what you see on the screen now. 2 hot wires going out and a ground wire coming back. That's a true 230 volt system. However, again, we're not going to recommend 2 single pole, single throw breakers. What we're going to recommend is a double pole, single throw breaker. As you go from hot to ground there, and then you go from hot to ground there, you're going to get 115 on each of those wires, okay? When you go hot to hot, now you're going to wind up with 230 volts, okay? So you go across those 2 hots, you're going to wind up with 230 volts. And that is the proper system, a double pole, single throw breaker. Double pole means I'm connected to both bus bars. Single pole means I've only got one thing to flip on and off. And either both sides are on or both sides are off. And that's why that's important. All right? Now, I had another guy call me up one time and says, geez, Bill, I don't understand this. I go hot to ground to get 115. I go hot to ground to get 115. But when I go hot to hot, I get 0. Now, of course, why is he getting 0? Well, you have to remember, when you're talking electricity here, you're talking about 2 115-volt lines. One line is positive, one line is negative. If you look at an AC current, you've got to have a positive and a negative to get the flow of electricity. So, if you're going to 2 positives like they are here, what are you going to get for a reading on voltage? 0. Nothing. Nada. Okay? So again, that's another reason not to use single pole, single throw breakers, because if you accidentally get in the same pole, you're not going to get any electricity out of it. Alright? So hot to hot produces nothing in this case here. Alright? So, now, continuing on with our electricity, we're going to look at the fact that we use something called a piggyback float switch. Now, I'm going to be perfectly honest, I like piggyback float switches. Not all of our pumps have piggyback float switches. The ones that don't have piggyback float switches, I have a tendency to not encourage people to use. All right? Here's the reason why. Because when you have a piggyback float switch, you can see the float switch is going to plug into the wall, and the power cord from the pump is going to plug into the float switch. All right? Now, this produces 2 very important factors, okay? One important factor is that if something happens and the pump stops working, you can always unplug the float from the wall, unplug the pump from the float, and then plug the pump in the wall. If the pump works, you know you got a faulty float. Makes it real simple to troubleshoot whether it's the float or not, okay? The other thing is, and this is a little more difficult, this is something that, I say, oh, geez, I really want to check this float to make sure that the float is the problem. Making sure that you put your ohm meter in the right place. Because putting your ohm meter on the 2 leads that are plugged in aren't going to get you anything. Because one is connected to the motor, and if the motor's not connected, you're not going to get a reading to it. So that's why you got to be careful to make sure that you get into the right place and make sure that you're seeing a flow of electricity that way. Okay? Now, let's talk about the floats for a second here. Again, there's several different types of floats. This is a wide-angle float switch. Now, you can see the white wire there. If you look on the one on the left-hand side, you see the black wire, so those are both connected. You can see that the float is in the open position right now. When it is down, it's considered open. So the floats that we use are normally open contact floats. Normally open contact floats mean when the float is hanging straight down, there is no contact, all right? What happens though is as the float moves up and gets in a vertical position, now we are going to have contact. You'll see that big steel ball that's in there moved from one side to the other, and when it did, the weight pulled it down and closed the points. Now what winds up happening is, as the float starts to float down, because of the fact that the water is getting lower, you'll see the ball is going to move, and when that ball gets back on the other side, you'll notice it opens up the points and turns the pump off. Most of the float switches we use nowadays are going to be mechanical. And the reason for that is more states are coming on board with anti-mercury floats. They don't like mercury because mercury is a poison, and so they don't like mercury because what usually winds up happening with a float switch when it's no good anymore, yes, it goes into the recycle, the garbage dump, okay? And you get those big heavy machines to run over the top of them, they break them open, now you get mercury floating into your groundwater, and that is not a good thing. So this is why they have really started pushing us to use mechanical type floats, all right? Now, the next thing we're going to look at here is what happens if the cord on the pump and the float aren't long enough to get to my main breaker box, all right? You'll notice here that we are going to go ahead and we are going to put it together a little differently. We're going to have a junction box. Inside that junction box, what we're going to do is we're going to take the two green wires. Now, the power cord for the pump has a green wire on it, and the source from the main is going to have a green wire on it. So we're going to take those two, and we're going to put them together, all right? We're going to take the black wire from the source and the black wire from the float, and we're going to put those together. So that way we have the electricity. It has to go through the float before it can get to the pump. Now, of course, what else that means is we're going to take the white cord from the float and the black cord from the pump and connect those two together. So that when the float comes up, the electricity goes from the black to the source to the black on the power cord. And then, of course, it has to return to the source, and so we're just going to take those two white cords and we'll put those two neutral white cords back together. The one from the float, from the power cord, and the one from the source. All right? A diaphragm switch. A diaphragm switch is nothing more than a pressure switch, but there's something very special about it. I'm going to wait till the end of this to show you that. We're going to do basically the exact same thing here. The ground wires are going to get connected together. We're going to connect the neutral wires together. We're going to take the black wire from the power and the black wire from the float and put those together. We're going to take the white wire from the float and the black power wire and hook those together. Now, what makes this so special? A diaphragm switch has to breathe. And so there is a vent tube with the cord, built into the cord. There's a vent tube. If you crimp the vent tube, the switch can't work properly, and you won't get it to turn on and off when it's supposed to. So be very careful when you're using a diaphragm switch, especially if you're going to do something like this, so that you do not crimp that vent. It's got to be able to breathe. If it can't breathe, the switch will not work properly. All right? And then the last thing we're going to look at here is what if we use a terminal strip inside of a junction box? The back of the strip looks like this. You can see each of those is connected to the other. All right? So on the front side, what we're going to do, we've got three cords coming in again. One is our source cord, one is our power cord, one is our flow switch cord. The green wires from the power cord and the source get connected there. The white wires from the power and the source get connected there. The black wire from the power gets connected to the black wire on the float. And, the black wire on the source gets connected to the black wire on the float. And the black wire on the power gets connected to the white one. All right? Everybody questions? All right, now the next thing we're going to do here is we're going to take a look at another type of switch. All right, this is sold through our Myers division, and this is a different kind of a float switch because it's actually got two floats that float on the water. And you're going to notice there, it says that there's three parts to this switch, okay? You'll notice the part right above where the switch turns on and off, you're either going to connect it to 115 or 230. Then it says normally open or normally closed. Remember, normally open is a pump down application, so that's a sewage application. Normally closed is a cistern, which means there's not enough water in there to turn the pump on. So we want to pump up, all right? The common wire is where we're going to connect to here. And if we're going to use 115, we are going to use a white wire to connect it to the common, okay? If we're using 230 volts, that wire is going to be black because remember, we've got black and red. So we'll either use the black or the red wire to connect to what we call the common there. Then there's going to be a hot wire that's going to connect to normally open if we want pump down. If we want pump up, we're going to take that black wire and we're going to move it to the normally closed position. And now we're doing pump up. Remember, pump down is normally open, pump up is normally closed. So if I'm running a sewage application, I want pump open or normally open. If I'm running a cistern, I want normally closed. All right? So this is how it really works. You've got a magnet. All right? You can see the two floats are hanging down. There's a spring. The spring's compressed. And, of course, the weight of the floats are holding it down. What winds up happening is that the water starts to come up. As the water starts to come up, it alleviates some of the pressure by taking the weight of the float off of the plunger. And as the weight of the float comes off the plunger, you can see the spring is decompressing now and pushing the plunger up. Once the plunger gets high enough, what happens is the magnet pulls and the switch over where the 115, 230 is, closes. All right? Once that closes, now what winds up happening is the pump turns on. Now remember, we're doing a pump down application here, and so when that pump turns on, the water starts to get pumped out, and again, you're going to wind up with those floats hanging, and that's going to cause the floats to turn back off. All right? Now, let's move into another arena here. We're still in electrical. We're going to look at a control panel. Now, I'm going to admit to you that this is a simplex system, simplex control panel, and I want you to understand that there are things in here that are going to be in there for sure. There are things in here that are optional, okay? Now, for example, that circuit breaker is optional. You don't have to have a circuit breaker in there. You can have a circuit breaker on the wall and put a disconnect switch between the circuit breaker here, or you can put the circuit breaker right in the box. If you want the circuit breaker built in the box, that may be a special order box. Okay, just understand that. Okay? The next thing we see here, there will be a motor contactor. Now, a contactor has a magnet in it. If you look carefully at the contactor, you see there's one wire. It's a white wire that's on the left-hand side and a red wire that's on the right-hand side. All right? Between those wires is a magnet. And when that magnet is energized, it's the float switches that energize that magnet. When that magnet is energized, now what winds up happening is it closes the contact and allows the electricity to flow through to the pump. All right? You're going to have two terminal blocks in here. One set of terminal blocks is designed for the pump. The other set of terminal blocks is designed for the floats. And of course, if you look carefully, you'll see the bottom one is for the pump and the top one is for the floats. All right? There's a wiring diagram telling you how to wire the pump to the box to make sure that it works properly. There is going to be a fuse, an alarm fuse and indicator right there. And next to it, there is a control fuse and indicator. So one's for the alarm, one's for the control, turning the pumps on and off. The other one is for the alarm, to make sure the alarm turns on and off properly. There's a pump run light. Now, obviously, with the door closed, you're not going to see it, but there's a pump run light there, okay? There is an HOA switch. HOA simply means hand-off auto. Now, this, we talked earlier, we were talking about electric, and I mentioned that you had a single pole, single throw breaker. This is a double throw. Double throw means that there is a neutral position. In this case, the neutral position is off. So if I throw it one way, hand means I'm overriding the float switches, and I'm going to close that contactor. When I put it back in the neutral position, that turns it off. And of course, if I turn it on, I have to turn it off. When I flip it to A, the other position, now I'm going to allow the float to determine when it turns on and when it turns off. All right? There is something called a TNS switch, and again, this is another double throw switch. The neutral position here simply means TNS is test, normal, and silent, so it means normal, which means that the float is in the on position. Excuse me, that the switch is in the on position for the float. So if the float happens to come up, it will turn the alarm on. Now, of course, these alarms can be excruciatingly loud and nasty, so what winds up happening is when you get to the job site, you want to go ahead and turn that thing off, and that's what S is for. So when you flip it down, you flip it into the S position, that's silence, and that turns the alarm off. The light still turns on because the alarm float is still in the on position, but now the noise is gone and you can think. If you want to test it, that's what the T is for, so you can test it. All right? So there's your alarm horn, and up on top is your beacon. Beacons can come red or yellow. It's up to you, whatever you want. All right? There's a UL label here to let you know this is a UL approved panel, and there's a ratings label on there to tell you how to run it. This is a duplex system. What you're going to notice in the duplex system is there are some things that are going to be duplicated. For example, there are 2 circuit breakers now, 1 for each pump. Remember, duplex means I have 2 pumps. There are going to be 2 of the contactors, 1 for each pump. All right? You will also notice that there are 2 HOA switches and 2 pump run lights, 1 for each pump. Okay? So the next thing that you're going to see there, terminal blocks. And again, remember what I said. There's 1 terminal block for each motor or each pump, and then there's a terminal block for the floats. So that's what you're seeing there. Float status indicator. There is a control alarm fuse. There is going to be a control off-on switch and indicator. So your TNS switch, you'll notice it's on the other side. It still does the same thing, just like your HOA switches. You'll notice there is only 1 TNS switch, though, and that's because there is only 1 alarm. And, of course, your alarm is down the bottom. Your beacon is up on top again. Okay? Again, there's a UL label listing there. There's a wire diagram to make sure you do it right. And there's a schematic there so you can see how it all gets wired. By the way, I just got to tell you, this is the box that your qualified electrician will destroy, because he'll look at it, he won't understand it, he'll rewire it, and you'll wind up buying a new one, because that won't be a warranty. All right? Now, just a couple more things here. This picture was taken out of the SSPMA Effluent pump book, and this is of a gravity feed system. Now, you'll notice there is a pump in the gravity feed system. It's that little sump pump over there on the left-hand side. I do want you to understand that pump has to be feeding from, I would imagine, a washing machine, because sump water, clear sump water that comes in around the house is not allowed in a septic tank. It dilutes in the good bacteria, and then you wind up having a problem. Now you'll notice it does give you a suggestion here of a minimum grade of 1 inch and 8 feet, a maximum grade of 1 inch and 4 feet. Again, what you're doing here coming out of the house is you're watching that velocity. Okay, you don't want it too fast, you don't want it too slow. Notice it suggests too that you're at least 10 feet from the house with the septic tank. All right, there's your septic tank. Coming out of your septic tank, a minimum grade of 1 inch and 8 feet. There is no maximum here. And of course, the reason being is there is no solids, so we don't have to worry about it, or real small solids. All right, there are what they call drop boxes. You can see 2 are installed. One looks like it's there just in case. All right, there's a hole in the top of the drop box. That's the highest hole. The bottom hole is where the laterals come out of, and then there's a hole that's kind of between them. That hole is there so that way if I don't plug it, it means that I'm using that hole to go down to the next drop box. Okay? So that's what that's for. Gravity feed systems, I've always told people that gravity feed systems are designed to fail. All right? Now the reason for that is because what you're going to find with a gravity feed system is you're going to find that the water goes out of the lateral like that. And of course that first drop box and that first set of laterals is the one that's going to get filled up the most. All right? Because of that, they're always going to be wet. And because they're always going to be wet, you're going to wind up having bacteria grow there. And so because bacteria is going to grow, those holes will eventually plug up and the system will fail. And now the water will have to go to the second drop box and eventually that third one. Now, of course, they could also be used if I'm using a lot of water. Remember, every gallon into a septic tank pushes a gallon out. So if I fill up my lines there, and now I have to push water down to the next drop box. But remember, those laterals get filled up first. All right? And again, that sump pump up there, it appears as though it's being connected to a washing machine, and that it's not just clear water. Okay? There's your elbow there that indicates to me that that's connected to some kind of a pipe. All right, now this is out of the SSPMA also, and again, one of the things that I don't think you're going to see too much of anymore is the septic tank buried that deep. I don't think you're going to see that. Okay, you may, but I kind of doubt it. Okay. The further down that septic tank goes, the more susceptible it is to popping up. And so you got to make sure you got enough weight to hold it down. Okay? If you got a high water table. There's your pumping chamber there. All right? And then over here is our drop boxes. So now we're pumping directly in. Remember, the last time we were pumping out of the house into the septic. Now we're pumping here into there, and that's going to be what we call a pump and dump, where we load the system up and then let gravity take over. Which means we have to calculate what each one of those laterals and drop boxes are going to hold. But that's for another school. Okay? So that's what we call a pump and dump system. This is what we call an LPP, low pipe pressure system. All right? And I do want you to understand there are 2 different systems here. There's an A system and there is a B system. The A system says, what if I have to pump up? The B system says, what if I have to pump down? So there are 2 different systems there. Okay? Low pipe pressure system can be used for absorption fields located above or below the septic tank. All right? You'll notice there is no drop box. No drop box. We're going to pump directly out. We may pump into a manifold and then have laterals go off that manifold, but we're going to pump directly out. There's no drop boxes. We're actually going to pressurize this system and force the water out of holes in the pipe. This over here, where you see the cap at, it's got to be below the frost line, and when you set this system up, the inspector's going to take that cap off, and what he's going to do is he is going to test the system. he is going to want a certain amount of squirt or water coming up. So he's going to get a measuring stick and he's going to measure how far the water comes up out of that hole. All right? Typically there's 4 of those, 1 on each corner, and he puts clear water in there and fills it up and turns it on and measures it to make sure that the same amount of water is coming out of each one. If there's too much water coming out, that means you don't have enough holes in your system. If there's not enough water coming out, then that means you've got too many holes in your system. And of course, he'll make you correct that, okay? You'll notice again over in our pumping chamber how we've got that pipe set up so that we're going to come up. We've got the 3 elbows in there. We've got the flow tree in there to turn the pump on and off. And so that way we're working just like we talked about before, all right? Now, there's 2 types of dosing. There's time dosing and there's float dosing. Time dosing basically says this. When the water in the pit gets high enough, there's 3 floats here, okay? The first float is going to be called your timer on float. The middle float is going to be called your timer override float, and the top float is going to be called your alarm float, all right? The way the system works basically is this. Water is going to be in the system, all right? As the system fills up with water and it gets above the timer on float, there is a timer. Now, dosing means every so often I'm going to turn this timer on. So if I have an 8-hour dosing period, if I have a 6-hour dosing period, it doesn't mean I'm going to turn it on for 6 hours. It means I'm going to wait 8 hours or I'm going to wait 6 hours, okay? The inspector's the one that's going to tell you that. Once the timer comes on, it starts clicking off that 6 or 8 hours. Now, the water could be at almost any level when that turns on, but it's going to turn on, all right? Eventually what happens is the 6 or 8 hours come up, and now we're going to wind up turning the pump on. When we turn the pump on, it's going to run for a 2-minute or 3-minute, 2.5 minutes, whatever we set it for, and then it's going to turn off. When it turns off, if it turns off above the timer on float, it starts another 6 or 8 hour cycle. If, however, it turns off below the timer on float, it turns off that cycle, and you have to wait until the water gets back up to the timer on float. All right? Now, let's say that it's Super Bowl Sunday, the party's at my house, and of course, we're drinking a lot of beer. And of course, because we're drinking a lot of beer, we're also using the restroom quite a bit. So we use the restroom more than what the septic tank can hold in an 8-hour system or a 6-hour system cycle, whatever. All right? And so, of course, what winds up happening is the level of the water gets up to the timer override flow. What that does is that says, I don't care if it's time to turn on or not, I'm turning the pump on. And so we'll turn the pump on and run the pump for the 2-minute cycle. Again, if when the pump turns off, and more than likely when the pump does turn off, you'll be above the timer on float. It doesn't start the cycle all over again. It just continues on until the cycle is done, and then it turns it on once again. All right? And, of course, lastly there, if you wind up with a pump that's gone bad, the alarm's going to come on and tell you, hey, stop using the system. All right? Float dosing is done a little bit differently. We kind of saw that system before. You're going to have 3 floats here. You're going to have an on float, you're going to have an off float, and you're going to have a alarm float. All right? Once again, basically what happens here is that these systems operate between the on and off level. Okay? Should something happen to the pump and it goes bad, now we're going to go up to the alarm and turn the alarm on. Basically what you're doing is you're measuring the distance between the on and off loads, and you're calculating how many gallons are there. This is, again, what we call a pump and dump. And so we're going to measure how many gallons are there, and we're going to pump that number of gallons out. And it's just simply by saying, okay, it doesn't need a timer. We're just going to turn it on when it needs to be on. We're going to turn it off when it needs to be off. Okay? A little different form there. This is called an aerobic system. So we're looking at anaerobic before from that septic tank. So if you look on your system here, you do have a septic tank in this system. That is a anaerobic. You're using good bacteria to kill off bad bacteria. Remember, you got 100 BOD count going in, 10 to 20 coming out. What's different about an aerobic treatment system is the simple fact that you're actually going to be pumping air into the aerobic treatment chamber. As you pump the air in the aerobic treatment chamber, you are now oxygenizing that water, and that oxygen kills off more bad bacteria. And of course, what that means is now, by the time the water moves from the aerobic treatment chamber to the pumping chamber, its BOD count is down very, very low. I do have to tell you one thing, though, and this is a true story. I've been down in Texas many times, and they do use these systems down in Texas. They are vented systems. Now, of course, what does that mean? That means that all the air you're pumping in, air is coming out. Now, you can imagine what that air smells like, and so why they did this, I don't know, but they had it right next to a barbecue. And I'll tell you, depending on which way the wind was blowing, it was heaven or hell. If the wind was blowing the right way, you could smell that barbecue, and man, that made you hungry. Wind was coming from the other way, well, let's just say you didn't feel much like eating, and it probably felt like you wanted to clean your teeth. Okay? So, and then from the pumping chamber, we're going to go out to the field. Because we've already lowered the BOD count, this field will last a long time. All right? Speaking of fields, this is a pump and dump field. You've actually got several things here. And you're going to notice that you're going to go in, you're going to take out some ground, and you're going to put in gravel. You want the number 6, the bigger stones. And you're actually going to put in 12 inches of it. Okay? You're going to put your 4-inch perforated pipes in, and you want to make sure that that stone is at least 2 inches above those perforated pipes. Then you're going to want some straw or fabric there, simply to keep the sandy loam out of the gravel. Okay? So you have 6 to 12 inches of sandy loam there, and of course the most important thing to remember is never drive a car on a septic field, because you will compress that sandy loam. The whole purpose of having sandy loam is to allow air to get down into that gravel. Okay? So you don't want to compress that. 3 different types here. These are alternate layouts. All right, this first type here is got a end manifold, so we are piping from our pumping chamber to the end of the manifold and then going down the manifold. Okay. The next one is the center manifold, and so we're pumping to the center of the manifold and then out each way. The last one here is called a middle manifold, where we actually run the manifold down the middle of the field and then pump our laterals out from there. Excuse me. A couple other things you want to remember here. Notice there's your septic tank. Next to your septic tank is your pump chamber, and of course you've got 2 fields. One field, they say, is just as an emergency field, so if that field dies, then you can set the other field up. I'm going to give you a little hint here. If you connect a pipe from your pumping chamber to both fields, so build both fields right away, connect a pipe to both fields right away, and then put a valve at that connection, so that one year you use one field, the next year you use the next field. That gives those fields a year to dry out, clean up, and get rid of the bacteria, and that means they will last a much, much longer time. So if you're concerned about your fields, that's one of the ways to control it, all right? Another very important thing to note in this picture is, here is the well. The well is fresh water. Every township is going to have their own law as to how far the well has to be away from the septic tank. In this picture, they're saying 100 feet. Where I lived up in Wandawega area north of Elkhorn, the setback was 50 feet. So it all depends on where you live as to what that setback is. Make sure you've got the correct setback. You don't want that septic water getting in with your well water. would not be very good, all right? And then lastly here, there's two types of fields. One is called a trenching system, the other is called a bed. You'll see in the bed, we dig the whole thing out, lay the pipes across there, cover it all up. And now we just let the air seep down through there and kill off the bad bacteria. In the trenching system, what you do is you dig trenches and lay your pipes in the trench. Some people feel that that separation allows for better bacterial removal. So it's up to you, all right? Our last picture here, once again, just shows us a typical gravity feed system. We come out of the house into the septic tank, from the septic tank to that first drop box. The drop box is going to send it out through the laterals. Remember, once those laterals are full, we're going to go down to the next drop box, and then out on those laterals, when those laterals are full, we're going to go to that last drop box. But it is designed to fail, all right? And again, this one here just shows the position of the drop boxes. If there's no further questions, thank you so much for your attention. I really appreciate it, and we look forward to seeing you on the next webinar. Thank you.